What's up, CP Finite? Welcome to 6.5 combinations. Very similar to permutations, only now order is not going to matter. So a combination is another arrangement, and its notation is NCR, is an arrangement without regard to order of R objects selected from N distinct objects. Basically, if you have a hand of cards, say you have, those are terrible cards, say you have a king, a queen, and another king. All right, that is the same thing as if you had a queen and two kings. Okay, that is all it's saying, that those are the same, so we can get rid of multiple examples of that. So, for example, the 10 people that call into a radio show, the first 10, okay, it doesn't particularly matter what order they call in. As long as they're one of the first 10, they all win a prize. Committees of equal rank, okay, say you're forming a subgroup out of 20 people and you just want 5 people in that group. That is a type of combination. Card hands, as we talked about, and another one, like how many ways can you arrange letters, okay? So NCR is similar to NPR in that it's the number of things, factorial, all over the number minus the rate at which you're selecting times the rate factorial. There's that extra little r factorial that will get rid of the redundant examples. That is formally, but really in the calculator you can simply find it similarly if you go to math. So say you want to take 10 and you do math PRB NCR 5, okay? You'll see that you get there. So it's under math, PRB, and then NCR. You need to enter the numbers in. You'll see it a few different ways. This here just means we have 12 and we are choosing 3. Okay? So if you type that into your calculator, 12 math, PRB, NCR 3, okay, you will find that equals 220. Similarly, this is simply 10C8. 10 things, you're choosing 8. Choose is a word typically associated with combinations. If you're choosing something, order does not particularly matter. I will be kind of specific, or I will try to be, at least in that case. And notice if we have 6 things and we choose all 6, we're actually going to get 1. There's only one way in order to choose all 6 things without order mattering. So just little tiny snippets of information there. More importantly are the application examples. So I talked about committees. So if we have 4 students from a group of 30 members. Now they are all on this committee, they all have the same title perhaps. The way you would solve this is you're taking 30 of them and you're choosing 4. So make sure that when you're doing these problems, I would like you to at least write down this aspect. That way I can give you partial credit. Perhaps you type it in wrong and that's why you get a wrong answer, or perhaps you do as I do sometimes and accidentally do NPR, but this case you get 27,405. Okay. Now notice, these numbers are different than 30 choose or permutation 4. So notice that they are different. They're slightly smaller because they're getting rid of all the extras. Okay, number of ways of selecting 10 courses. It doesn't matter what order you take those courses in, you just need to select 10 of them. So 400 choose 10. We'll see that here. 400 math PRB choose 10, boom, boom, boom. And oh my gosh, there's still a lot of them, 2.57. Just do about 2 decimal points times 10 to the 19th. All right, so when you go to college and there's all those different courses, there's a ton of different ways. Now, order might be a little more particular in that case, but in general, that's different. The different amount of ways, sorry. The number of 5 card hands that could be dealt from a standard deck of playing cards. Just note, standard deck of playing cards is 52 cards. Okay, if you're not too familiar with a standard deck, you will be by the end of this class. I'll give you some of the details later, but 52 cards. That means a dealer is handing you 5 cards, so 1, 2, 3, 4, 5, and what ends up happening is you have 52, and essentially you're choosing 5 of them. So this is why poker and a lot of card games are so big. It's because there are so many different combinations of hands that you could get. So there's 2, 5, 9, 8, 9, 6, 0. 2, 5, 9, 8, 9, 6, 0. 2 million some hands. Number of ways a committee can be selected with 3 juniors and 4 seniors if there are 10 juniors and 20 seniors available. So here we have a little different type of thing. Okay? First off, when you see the word and, something should go off in your mind. That means to multiply. And means to multiply. And means to multiply. What does it mean? It means to multiply. Okay? So here we have a committee, and we actually have 2 different things. We have juniors, and we have seniors. And, so we know we're going to multiply something. Now, what we want to do is decide how many ways I can choose the juniors. The juniors can be chosen. I want 4 of them. Actually, sorry, I want 3 of them. And there are 10. So that means I want 10 choosing 3. That fills up my juniors. Okay? As for seniors, the way I can choose my seniors, I want 4 of them, and there are 20 available. So 20 choose 4. Now, when you type this into your calculator, you can do this whole thing. I definitely want to see this written out. Again, if you're making a committee and there's 2 different things, you need to multiply. Okay, do not add. So I'll use my other calculator here. 10 math NCR 3 times 20 math NCR 4. There are 581,400 different ways that could be made. Okay? Arranging the letters. These are common questions, something you might even see on the SATs. First off, you want to tally up the number of letters. There are 11 total letters. So we're going to write that as 11 factorial. So there's 11 ways we can arrange all the letters. So there's the total letters. But we want to divide that, because if we rearrange the I's, okay, it's really going to look the same no matter how we put them. So what we want to do is we want to divide by, in this case, 1, 2, 3, 4 factorials. That will take out the redundant I's. There's 4 of them, so we're going to take those out. Now there's also redundant S's. So 1, 2, 3, 4. So also we are going to take out the 4 of the S's. And lastly, we have redundant P's. So we're going to take out 2 of the P. Now I even recommend writing out these little things, okay? That way you can keep track of all the different numbers. Now if you type this in your calculator, make sure that you do all of the denominator in parentheses. That's how you want to do it for the calculator. Make sure you have the parentheses there, otherwise you will get an incorrect answer. So from here you can type everything in. Again, I would encourage you, show your work. It's really no big deal. Times 4 math factorial times 2 math factorial, and parentheses, enter. You have 3, 4, 6, 5, 0 different ways. The most challenging problems are these here, the at least and at most. When you see these, I want you to think at means add. At equals add. At means to add. We're going to be adding different scenarios. So from 6 Democrats and 4 Republicans, a committee of 3 must be formed. How many ways can the committee be formed if there must be at least 2 Democrats? Okay, so at least 2 Democrats. So let's just do some writing here. At least 2 Democrats, we need a committee of 3. What are the different scenarios you can have? So if I need at least 2 Democrats, That means I can have 2 Democrats and 1 Republican. Okay? That is one way to fill that requirement. Or I can have 3 Democrats and 0 Republicans. Okay, so there's scenario 2. This is how I would really encourage you to write these at least problems out. Once you do that, you can decide, well, how can I choose my 2 Democrats? Well, there are 6 of them on the committee, and I want at least 2. So I would have 6 choose 2. Republicans, I'm going to have 4, and I want 1 of them. These numbers on the end are always going to add up to the total number in your committee. So that's one way. Now I'm going to add that to the other way. In this case, I need 6 Democrats, and I'm choosing 3 of them. And then I'm going to, and by the way, it's multiplication in between. Okay? Multiplication in between the particular cases times 4 choose 0. And that is how you want to write out your work for these. You might have a few more scenarios, I'll show you in a second, but that's how you write out your answer. And you can type this entire thing into your calculator. Okay, just make sure you have plus in the multiplication. So 6 NCR 2 times 4 NCR 1 plus 6 NCR 3 and 4 choose 0. There are 80 different ways to go about that. Okay? Now, committee of 3, at most 1 Republican. Okay? So at most, this is kind of similar, but notice, scenario 1. We can have 1 Republican and 2 Democrats. Or we can have scenario 2, in which we have 0 Republicans and 3 Democrats. So those are the 2 things. Now notice you actually have the same problem as that above. The ways I can choose my Republicans are 4 choose 1 times 6 choose 2 plus 0 Republicans is 4 choose 0 times 6 choose 3. It's the same exact combination, only this one is worded at most. Okay, so do be aware of that. Write out the different cases. You might have more than 3 things being formed, okay, or more than 3 things. You might have 3 scenarios, maybe even 4. But I encourage you to write them down. Again, the numbers on the end should always add up to the number in your committee. Okay, so awesome stuff. Take your time on those. Other than the at most, I think it's pretty easy. Take your best shot at some problems after this. You have some examples. You also have a exit or a checkpoint on Schoology. So thanks, guys. Make sure that you have all those down, and we'll see you again.